Hello everyone, welcome to our channel Boarding Physics. Today our topic is class 10 force. So let's start the chapter force. In case of force, we know already that force from class 9 we have learned this part F equal to dp by dt equal to we have written ddt of p means momentum means m into v. So from there we can write m is a constant term, we can take it out, and ddt of v means we can say dv by dt. So we can write easily mass into acceleration. This part already we have done in class 9. And what about the unit of force? If we say the unit of force in SI system, we have written that Newton, and in cgs system we have written that is called dyne. So this part already we have done. Now we have to know in class 10 the first thing, that is the moment of force. In case of moment of force, when we have to know about the motions. Okay, we have to know about motions. So how many types of motions we have to introduce here? Here basically we have to introduce two types of motion. One is called linear motion. So one is called linear motion and another one is called rotational motion. We have to start. What is linear motion? Let's see first what is linear motion. Linear motion, or you can say also that is called translational motion. Translational motion also you can say. Now what is linear motion or translational motion? Basically, in one word, if I say that whenever we have to apply some force on a body will move in a straight line path. Suppose if we say this is a path, one body we are having, this is the body. So suppose if we apply some force on it, so what will happen? Body will move in this direction. So what basically we can say, by applying the force, so we can say by applying some force, the body starts moving in a straight path in the direction of force. Is called linear motion. So linear motion, when we have to apply some force, body will move in a straight line path, that is called linear motion. Now our next topic is rotational motion. Let's see. Rotational motion. What is rotational motion? Rotational motion means, suppose we can say that we are having a body. This is the body, and in the middle we have a point that is called pivot point, or pivot point also you can say, that is called pivot point. If we apply some force on it, so body will move either clockwise or anti-clockwise rotation, means like a wheel. It can act as a wheel, you can say. So when we are applying the force in this position, so body will move in this way. This way means we can say that clockwise rotation. So in this case, with respect to this pivot point, this one always keep it in your mind. Basically this is a turning effect of the force. We can say that if a body, it can pivot it at a point, if we apply some force on it in any position, any suitable position, you can choose here, you can choose here also the force, okay. But if we apply some force in this position, then body will move in the opposite direction, okay. This thing always we have to keep it in our mind. So whenever we have to apply some force, body will rotate about the axis passing through the pivoted point. So whenever the body is moving with the axis and passing through the pivoted point, we are telling this one the turning effect of the body. So we can say that in one word, the turning effect, of the force and the motion of a body is called rotational motion. So these are the basic things. Translational and rotational motion already we have done. The next part, which one we have, that is called moment of force. Let's see. Next part, we can say moment of force. Moment of force. Let's see how we can do. Moment of force or torque, also you can say moment of force, or we can say that the turning effect of force, or you can say that torque also. Torque is denoted as tau. Keep it in your mind, okay. Torque. In this case, how we can say, suppose we can say that we are having a body. Suppose this one is having a body is pivoted at a point. Suppose that the pivot point, we are telling this one, that is suppose A is the pivot point, okay. Now we are applying some force on it. Suppose in this direction I am applying some force, this position applying some force, so obviously body will move in this direction, should have to be. Now what we have to say, that the moment of force means force into the perpendicular distance, force into the perpendicular distance of the line of action of the force from the axis of rotation. Now pivot point is A, we have got it. Now if we say that the force is this one, force we are applying over here. Now if we want to calculate the perpendicular distance of the line of action of force, so line of action of force means this way, lines of actions of force. Now what is the perpendicular distance? Perpendicular distance from the pivoted point, so we can easily say this is the perpendicular distance. So suppose this point we are taking B, so what will be the perpendicular distance? That is AB. So we are telling that what is the moment of force? If you say moment of force, you can say O also. So moment equal to, you can say moment of force equal to, we can say force into the perpendicular distance of the line of action of the force from the axis of rotation. So means here pivoted point is this one, that is the axis on which the body can rotates, and from there the force is this position we have applied. So perpendicular distance of the line of action, so line of action is this one, this is the line of action we can say. And what about the perpendicular distance? That is A to B. So AB is the perpendicular distance. So moment of force, when we have to calculate, we can say force into the perpendicular distance, that is AB, F into AB. That will be denoted as the moment of force. So after that, one question can come, what are the factors which can affect the turning effect of the body? Factors is very easy, already we know. Factors, the first one you can say magnitude of force. We can say that the magnitude of force, this one. And number two, obviously we can say that is the perpendicular distance of the line of action. Perpendicular distance of the line of action of the force from the axis of rotation or from the pivot point. Any one you can write. Okay, so this is known as the moment of force. Now we have to calculate what is the unit of moment of force. Let's see the unit of moment of force. Unit of moment of force. So let's see what are the units of moments of force. Units of moment of force. So we have seen that moment means force into the perpendicular distance. So force unit, suppose if we say for SI system, in SI system force unit is Newton, already we know. Into the perpendicular distance is meter, so Newton meter you can say. Suppose if we say in CGS system, what it will be? It should be dyne into centimeter. So here is Newton meter in SI system, here is dyne centimeter in CGS system. Why? Because unit of force in SI system is Newton, and the perpendicular distance and the distance is same. Distance unit is meter in SI system, so we can say Newton into meter. Now there is one relation in between Newton meter and dyne centimeter. Let's see that one. Suppose if we say 1 Newton meter, one question can come also. 1 Newton meter equal to how much dyne centimeter? This is a common question, it can come, okay, for 1 mark or 2 mark question. So let's see how we can calculate. 1 Newton meter equal to, we can write 1 Newton into 1 meter, right? So 1 Newton means, we can say 1 Newton means already we know 10 to the power 5 dyne into 1 meter. 1 meter means 100 centimeter. 100 centimeter. So we can say that 10 to the power 5 into 100. So 10 to the power 5 into 10 square dyne centimeter. So we can say 10 to the power 7 dyne centimeter. 1 Newton meter equal to 10 to the power 7 dyne centimeter. So this one is the important one. If you are having any doubt in between, you just write a comment in the comment box. I'll give you the reply. Okay. So the next topic we are having clockwise and anti-clockwise moment. Let's see first. Clockwise and anti-clockwise moments. Now we have to introduce the clockwise moments. What about the clockwise moments? Suppose we are having a body. Okay. We are applying some force in this direction or in this point. So obviously if we apply some force in this direction, body will rotate in this direction. So this one is known as the clockwise moment. So what you can say that which one is called the clockwise moment? This one is the pivoted point. We can say that the effect on the body is to turn it clockwise. Then what about the moment of force? That will be known as the clockwise moment. In the same way, if just opposite direction, if we apply the force, then it will be in the anti-clockwise. Let's see. Suppose the body is this one. This is the body. If we are applying the force in this position, what will happen? Body should have to move in this way. This is the pivoted point. So that means that is known as the anti-clockwise moment or anti-clockwise motion. Anti-clockwise. Okay. So in which position we are applying the force, that will be denote that either the moment of force will be clockwise or anti-clockwise. So generally in case of the clockwise moment, we are taking it as a negative, and anti-clockwise moment basically we are taking as positive. Okay, so keep it in your mind. This is very, very important part of this topic. So the next topic which one we have to discuss, that is called couple. Couple. What is couple? Basically we can say that uh, pair of forces. Pair of forces means two equal and opposite or parallel forces, they have to acting on the same body but not acting along the same line. Suppose what we can say, steering of wheel. Suppose we can say that this one is a steering. Suppose we are taking this one is a steering. We are taking this one is a steering. In this part it should be like this, more or less should be like this. Okay, suppose if we say that this is steering, what we have to do in this portion, we have to apply, we have to hold one hand, and this side we have to hold another one hand, right? So this side, suppose we are moving in the clockwise direction, this one we are moving in clockwise direction, and this hand we are moving in anti-clockwise direction. Suppose it can be the opposite also, sometimes we are moving this side in this direction, this side in this direction, it can be, but suppose in one case we are telling. So if we say that both the cases for a steering, the holding two hands, we are applying some force. So in this portion we are applying force, in this portion we are applying the force by our two hands. So in this direction, what about the force we are applying? In this direction means we are applying the force over here, and in this direction we are applying the force over here, we are applying the force. Now see, both the forces are acting on the same body but in the opposite direction, right? Opposite direction but not acting along the same line. So this thing is known as the couple. Okay, so what is couple? We can say two equal and opposite, equal and opposite parallel forces. Parallel forces which are not acting on the same line, on the same line, forms a couple, forms a couple. This one only one example I have given. Car wrench also we can say, when we are turning a water tap, we can say, turning a key and lock, we can say, when we can open a bottle, on that time also we can say we are using that the couple, means two forces acting opposite direction, parallel forces acting opposite direction, that way we can make that the couple. Now we have to calculate the moment of couple. Let's see what is called the moment of couple. Moment of couple. Let's see how we can do the moment of couple. In case of moment of couple, we can say, suppose we have taken a bar, okay, AB is a bar we are taking. We are applying the force in the both opposite direction, okay. So this way we are applying some force, same this way we are applying some force, okay. This point we are taking the midpoint. Suppose we are taking O. What about the distance between the applying forces in the 2 points A and B? Suppose we are taking the distance is small d, okay. Now see, we can easily say if we apply some force in this direction, we know that body will move in this way, means in the anti-clockwise direction, and in same way when the body is moving, we are applying the force at A, the body will move in this direction, means it should be the anti-clockwise direction. Now we can say that whenever we have to applying the force F at A, so we can say that we can calculate the moment of force at A equal to, we can say, force into O into A, F into OA, we can say. So now if we calculate the moment of force at B, so suppose we are calculating the moment of force at B, that should be equal to how much? We can say F into OB. Now what will be the total moment if we have to calculate? Both are in the anti-clockwise moment. Here also anti-clockwise moment, here also we are getting anti-clockwise moment. So what about the total moment if we want to calculate? Let's see. Total moment. We can say total moment means F into OA plus F into OB. So we can write that F into, both we can take OA plus OB. So OA plus OB means the total AB, means we can write F into AB equal to, we can say, AB. AB means D, so we can write F into D only. So this one is called moment of a couple. So moment of couple also same, force into the perpendicular distance between the two forces or the couple arm. So this way also we can calculate the moment of couple, okay. Keep it in your mind. Next topic we are having that the equilibrium of bodies. Almost the same concept we have to use over here, that is equilibrium of bodies. What is equilibrium of bodies? Let's see. Suppose if we apply some forces on a body, but there is no change, okay, there is no change in the bodies, that is called basically the equilibrium of bodies. Equilibrium of bodies, basically we are having that the two types. Equilibrium of bodies, basically we are having two types. One is called static equilibrium, and number two we are having, that is called dynamic equilibrium. dynamic equilibrium. Static equilibrium, when a body remains in the state of rest. If we apply some forces, also it should be in the rest position only. That is called static equilibrium. Means if we say that what is called the static equilibrium, we can write when body remains in the state of rest. In the state of rest under the influence of forces. Of forces. This is called static equilibrium. Static equilibrium. And if we say about the dynamic equilibrium, dynamic equilibrium means you can say when the body is in state of motion. Either it can be translational or rotational motion. So if we say what is the dynamic equilibrium, suppose if we say when a body same to same remains in the state of motion, in the state of motion under the influence of several forces. This is called dynamic equilibrium. This is called dynamic equilibrium. So in this case, generally you can ask for the examples. Suppose if you say for the static equilibrium. Static equilibrium means any object which one is in rest in our surrounding. Suppose any body, any book is on the table. So if we are applying some forces on that body also, but the position is not changing, that should be called the static equilibrium. In this case, we know that weight of the book, so obviously exerted on the table, it should be downwards, and the same way equal and opposite force of reaction exerted on the table on the book vertically upwards. So we can say that this book should be in static equilibrium. In case of dynamic equilibrium, what we can say, aeroplane moves at a constant height, but when it is lifting, it balances its weight downwards. So body is in motion, but it balancing its weight at a constant height upward direction due to the balance weight downward direction. So these are the examples of the dynamic and the static equilibrium. Next, which one we have, that is called, so many other examples also you will get through whatever the books you are using. In your book also you will get. Next topic, which one we are having? Conditions for equilibrium. Conditions for equilibrium. Conditions for equilibrium, basic two conditions we are having. Number one, what about the total forces acting on the body should be zero. So you can say that the resultant forces acting on the body is 0. And number two, algebraic sum of the moment of force. Algebraic sum of moments of all the forces acting on the body about the point of rotation is 0. So these are the two conditions for equilibrium, you can say. So from this only we will get another one thing, which one is called the principle of moments. Principle of moments. First of all, we will do that all the theory parts from the chapters, and then the last video I'll make for the numericals, all the type of numerical which one is come in the board exams for class 10, cbse, icse, what type of numericals can come, that one we'll keep at the last. Okay, so let's see. Next topic, we can say principle of moments. This is almost similar how we have done that the moment of couple, almost like that. Let's see. Principle of moments. Principle of moments. What is the principle of moments? Basically, the principle of moment says sum of the anti-clockwise moment equal to sum of the clockwise moment. Means what we can say? Sum of clockwise moment equal to sum of anti-clockwise moments. So in this case, how we can identify this one? There is also one way we can identify this. Let's see. With respect to this, so many numericals also it can come. Suppose we are having a bar or a meter rule. Suppose we are having a meter rule, a big meter rule we have taken. Okay, this point is, suppose we are giving A, and suppose in between this point we are giving B. Meter rule means it should be like this. like this. Now suppose we are having the two springs in the both the ends A and B, and it is supported at one end. Suppose in this position it is hanged. This is hanged in this position. Okay, one support is there. So suppose in this point we are having one spring, and with the spring suppose we are having some weight also, some amount of weight we are having. Suppose this weight we are telling W1. Okay, so obviously it will move in this direction, means clockwise moment, we can easily say. Same way, suppose at B, at the position B, we are having another one spring, some amount of weight is there also. This, suppose this one is known as W2. This one moving in this direction obviously, so this one should be anti-clockwise movement. Now what about the length? So suppose this point we are taking C, so A to C, the length we are taking, suppose L1, capital L1, and from here we are taking B to C, the length is L2. Now in this case, the both the ways we have to calculate the moments. So now suppose if we calculate the clockwise moment, if we want to calculate the clockwise moment, at A, okay, what we'll get? Moment means we know that force into perpendicular distance. Here force is W1, so force into perpendicular distance. So here force means W1 into, what about the perpendicular distance? That is AC. So W into AC we can say. In this case, second part, anti-clockwise moment, we can calculate anti-clockwise moment at B. So we can say force into perpendicular distance. So we can say what? W2 into, we can write BC. So clockwise moment W into AC, and this one W2 into BC. So we know that according to the principle of moments, according to the principle of moments, what we can say? Clockwise moment equal to anti-clockwise moment. Sum of clockwise moment, sum of, equal to sum of anti-clockwise moment. So what we can say from here? W1 into AC equal to W2 into BC. So W1 into, we can say, L1 equal to W2 into L2. So this is basically known as the principle of moments. Principle of moments. Keep it in your mind, very, very important part from this chapter.